are two types of elimination reactions. One of them, just like substitution reactions, one of them is called E2, one of them is called E1. So we had SN1 and SN2, now we have E1 and E2. Let's start with E2. Again, E2 happens in one step, is second order, and is mainly good for primary alkyl halides. There is one more condition here, is that our alkyl halide should have hydrogen and halogen in anti-periplanar position. Basically, what the anti-periplanar position means, opposite of each other. So when you look at its Newman projection, it should look like something like this. Hydrogen, and then halogen to the anti-position, okay? Or if you want a wedge and dash, it must have such a geometry. But why? Because E2, let's work on this. E2 happens in, we said, one step. So what did we say at the beginning of this chapter? It includes a base. A base like, let's say, OH, okay? And what happens is that, oops, I made a mistake here. So let's first check. Is it a primary alkyl halide? Yes, because carbon connected to halogen is just connected to one more carbon. Does it have hydrogen and halogen opposite of each other in anti-periplanar position? Yes. So what happens, this is the difference between elimination and substitution. What happens here is that the base attacks hydrogen. So instead of coming and attacking the electrophile, now it attacks the hydrogen. The bond between hydrogen and carbon shifts between the two carbons because we are getting prepared to form an alkene. And then halogen leaves. So since there should be a formation of double bond, it's between the two carbons. Hydrogen must be on one of the carbons and halogen on the next carbon, but on the opposite side. So what happens here is there is just one step, step one, the only step, and that's the rate determining step, of course, because there's no more step there. And then there would be no hydrogen here, so this carbon is going to be connected to two hydrogens. We just said the bond collapses between the two carbons, so we form a double bond, and there would be no halogen, so this carbon will also carry two hydrogens only. And OH has been added to H, so if you're looking for the other products, you will have H2O and your halide. That's your alkene product. The product of elimination process is always an alkene. So what are the requirements for E2 besides hydrogen and halogen on the opposite sides? As far as the base, we need a bulky base, a big base. Maybe this base that I chose is not a good one. So if I have added something like CH3, CH2O would be a better choice. Because this base is big, it cannot go and attack carbon. So instead, it just grabs the hydrogen, which is in the anti-periplanar position of halogen. What is the job of the base? At absorbing one hydrogen. So the bulky bases are better. We can also use OH and some OR. That was OR, right? This here I use OH. You can also use OR, like what? Like CH3, CH2O that I told you. So other bases like DBN and DBU, you have their structure on the study guide on page 3. Don't worry about their full name. You don't need them. So you see their bulky bases. They are used also. As far as the leaving group, of course, everything happens at the same time. So the better the leaving group, the better. We said it's second order, so rate equation is written as K base and Rx alkyl halide. That's the meaning of second order. That's why it's called E2. As far as the solvent, we need a polar solvent, but a product. But a product means that we don't need a hydrogen because it's going to distract the base. We want base to grab this hydrogen, not the hydrogen from our solvent. And as far as the substrate, we said primary alkyl halides or substrates are better for this purpose. Let's talk about E1 reactions now. E1 reactions, they have no geometric requirements. It happens in 2 steps. Step 1 is formation of carbocation or carbocation. I don't like that word. Carbocation is what I'm more familiar with. Formation of carbocation, and it would be your rate determining step. So it's first order. E1, 1 is for first order, and it's mostly good for tertiary alkyl halides. Why? Because of carbocation formation. The tertiary carbocation is the best. So let's apply it on this molecule. There is no geometry requirements, so we don't have to have a hydrogen in anti-periplanar because it happens in 2 steps. So CH3, CCl, CH3, the same example you have. The first step, which is rate determining step, very similar to what you had in SN1. First, chlorine departs the molecule. That's a rate determining step because losing the chlorine, losing the halogen, breaking this bond is difficult. So we will have CH3, CH3, and allow me to, it can happen to any of these. They have the same value. The hydrogens on each of these carbons have the same value on this particular molecule. So what happens is that the base comes, and of course you have this chloride here. The base comes, grabs the hydrogen, and that's where double bond forms. So at the end we have 2 CH3 groups on this carbon and 2 hydrogen, and plus you have chloride and hydrogen and the other products which are not very important for us. The requirements for E1 are the base should be a weaker base than E2 reaction. Living groups, of course, the better living groups, the better. Solvents is okay if you use polar product, doesn't matter, the proton does not interfere in the mechanism because there is no nucleophile in the first one, in the first step. And the substrate, we said for the tertiary alkyl halides, it's better. And since this is the rate determining step, the rate equation is going to be just alkyl halide. That's the meaning of first order. Alright, so we always have the competition between especially E1 and SN1, but also between E2 and SN2. So we have to consider different factors in the particular reaction. Now it's time to work on different examples. The first practice says use curved arrows to show the movement of electrons in the following E2 mechanism. In the following E2 mechanism. And okay. So here it says an E2 mechanism, so hydrogen is here. Why? Because the double bond must be formed between these two carbons. And it seems like the base attacks hydrogen, double bond forms, and bromine is going to be kicked out. That's the mechanism for this. The second practice is asking for, let's work on one of them. I will work on B. It's asking for rank the alkyl halides in each group in order of increasing reactivity in an E2 reaction. What type of alkyl halide do you have here? Carbon carrying chlorine connected to one more carbon, so it's primary. The second one, carbon connected to chlorine is connected to 3 more carbons, so it's a tertiary. And carbon connected to chlorine connected to 2 more carbons. The requirement for E2 is that E2 is better with primary alkyl halides. So primary alkyl halide is the best. Then the secondary and the most crowded one is not very suitable for an E2 mechanism. All right? You do A, the same way, the same approach is applied. The last practice on page 4 is asking for drawing a mechanism for this reaction. Okay, so let's see if this reaction really has the requirements of an E1 reaction. The tertiary alkyl halide is here, right? Carbon connected to chlorine connected to 3 more carbons, and it's a weak base. It's not a very strong base. So the situation is ready for an SN1 reaction. What happens at SN1 reaction? The first step is that molecule spends energy to get rid of its halogen atom. Step 1. Which one was the rate determining step? This one. So we will have the formation of tertiary carbocation. This is a tertiary carbocation. It's a pretty stable carbocation. And then in the second step, we have the hydrogen here, right? On the next carbon. Oops. All right. So is it the same as here? Yes. If I put it completely vertical. And then base has grabbed this hydrogen, so we change this to OH2 positive. And chloride is the one which departed the first and the second step. This is the second step. So that's how you work on this type of question. Okay. Next thing on page 5 is asking what alkenes are formed from each alkyl halide by an E1 reaction. So I do not draw the mechanism. I'm sure at this point you know how to draw the mechanism. It's an E1, okay? So in E1, first this chlorine is going to move out, and then the base is going to grab the hydrogen here. So eventually we will be having a double bond here. Or we say there is a hydrogen here. So, right, in the second part, the hydrogen can be deducted. This carbon has two adjacent carbons, right? We can have double bond here. Do you see any difference between these two? If you want to name this compound, it's the same as if like you flipped it. So it's just, these are identical. So it's just one product. Why do we say it's the same? First, from the name. Second, right now we are not very good at naming alkenes. So we go by the substituents. Look at this. 1, 2, 3 substituents. And here we have 1, 2, and 3 substituents. So the number of substituents are the same. Both of them are cis, so they're identical and one product. But for B, look what happens. E1. First, in the first step, let me draw the first step here to save some space. What happens in the first step? The molecule gets rid of its halogen. A tertiary carbocation is formed. Then there are two carbons, right? So we have the base attacking the hydrogen here or the hydrogen here. So we will have two products. Or oops. Now let's determine the stability. 1, 2, 3, and 4. 4 substituents. And here, 1, 2, and 3. Now, it's time to introduce Zaitsev's rule. Zaitsev's rule says in elimination from alkyl halides, the alkene with more substituents on double bond is the major product. So if there is a difference between the number of substituents on the alkenes produced from elimination reaction of an alkyl halide, the alkene with more substituents on double bond is preferred. That will be our major product. Okay. Next question. I'll do one of each. You will do the next one to practice more. The first one is asking draw both SN1 and E1 products for each one. So I will work on A, on the cyclic compound, plus H2O. It just says draw the products. I explained the mechanism. I hope you understand. SN1 attacks first the departure of bromine, and then H2O is going to be substituting bromine. So OH2O, right? And then a second H2O comes to stabilize to grab one hydrogen and stabilize the charge on OH. You remember the last video we said oxygen cannot tolerate positive charge? So an alcohol is the substitution product of this reaction. In E1, both of the first steps are the same. In E1, bromine is going to be departed. Carbocation is going to be formed, but this time the hydrogen is going, one of the hydrogens of here, according to the Zlat rule, is going to be grabbed by H2O. So the final product is going to be an alkene. You cannot count on the hydrogen here because it's going to be less substituted product, and according to Zlat rule, you should choose this carbon or this carbon. The next practice is asking for giving the product of E2 for the product. So since we worked on A, last practice, let's work on B. Okay, why are we insisting on putting the wedge and dash? Because for E2, remember that hydrogen and halogen must be in the anti-periplanar position. Do you see them? Yes, we do. So base attacks hydrogen, double bond forms from the electrons left from hydrogen, and bromine is going to leave. So going to have C6H5. Or just doesn't matter anymore. So we will have the C6H5 and hydrogen. Okay? If you want the exact geometry, is that this one comes to the front probably, this one goes to the back, and this one comes to the front. Why? Because C6H5 are big, we don't want them to the same side. And the last one on this page, it says explain why 6,1-chloro 2-methyl cyclohexane undergoes E2 elimination much faster than its cis isomer, than its trans isomer, I'm sorry. This is cis, 1-chloro-2-methyl. So means that there is a hydrogen here and there is a hydrogen here. Of course, we don't need the one next to chlorine. So you see chlorine and hydrogen in the anti-periplanar. This is for cis, but position. But for trans, you see hydrogen and chlorine are going to be on the same side, not the anti-periplanar position. On page 6, we are supposed to first determine which mechanism is going to happen. You work on a couple of them, you work on the rest. I will work on decided C and D. So let's see the requirements. What type of alkyl halide do we have? Tertiary, and it's a weak base, right? That's the remedy for SN1. At the end, you will end up having an alkene. Can you say which alkene? That will be your practice. The next one is the reaction between a primary alkyl halide and a strong and big, bulky base. Do you see? Bulky base, 3 CH3 groups. It makes it a big base, so there would be, I'm sorry, I don't know why you put SM1, it's E1. And the second one is the recipe for E2. Now, we know about E1 and E2 going from an alkyl halide to an alkene. But what if we have extra base? You add more than enough extra base. In the presence of extra base, alkyl halide is going to change to an alkyne. First it changes to an alkene, but since you have extra base, it will change to an alkyne. Look what happens here. We call it a vicinal alkyl halide. Alkyl halide. Why do we call it vicinal alkyl halide? Because halogen atoms are on two neighbor carbons. Or instead of neighbor, let's call it adjacent. So with E2, what is going to be eliminated? An HX, right? This hydrogen and let's say this, doesn't matter which one first. But so we have X, let's put R here, the same as what you have on study guide. And then you have H, then you had the H and X in anti-periplanar position, then you have it again. With an extra base, you have another elimination of HX. So be careful, if on the arrow is written extra or excess, means that you need to have the alkyne. So you have R, C, R. And the same thing about a geminal dihalide. We have vicinal. What if the halogen atoms are on the same carbon? Can happen too. Geminal dihalide. I should have said vicinal dihalide, and this is geminal dihalide. Halogen atoms are on the same carbon. That's the meaning of geminal. So E2 happens, but still the requirement for E2 is to have hydrogen and halogen atoms on the antiperiplanar. So the base, whatever the base is here, is NH2, right? Same as before, I didn't show it. So we have the first formation of our alkene. Again, you have them in antiperiplanar position. The second, the excess base comes, grabs it, forms a triple bond, and kicks the second halogen out. E2, another HX will be removed. So if you have extra base, this is what's going to happen, excess or extra base. The next question is asking for it. I will just work on A. It says draw the alkyne formed. It's a vicinal dihalide, right? In extra base, excess in H2. So first, you have hydrogen here, doesn't matter which one is being attacked first. This hydrogen kicking this here. So this will be kicked out because these two must be in the antiperiplanar. Then we have chlorine here and a hydrogen here, but there is a double bond. Then the next extra molecule comes, kicks it out, forms the triple bond, and forms our final product. Correct? Okay, you can work on the rest. And finally, there's always a competition between SN1 and SN2, E1 and E2. You can go over the summary of them. At the end, we have to choose between or just predict which one will happen. For example, first one. So you see a big bulky base, right? And a primary alkyl halide. So it's going to be E2. let's say for C, it's a tertiary alkyl halide, correct? 1, 2, 3. CH3, CH2, OH. It's a weak base and nucleophile, so it's either SN1 or E1. Okay, I hope it was a useful review on these concepts. Good luck with the studies for this chapter.